All right, welcome to week 9 here. This is going to be our SQL lesson. We're going to be going for case statements and temp tables. Now, temp stands for temporary tables. These are two of the more advanced features in SQL, and you're not really going to be tested on this. I just kind of want to let you know. And then after we go through this, I'm going to go into a little review of some of the SQL we've already covered. That never hurts to review. But let's go ahead, pop over to our slide deck, and we got SQL case statements and temp tables. All right, so a case statement, hold on, let me adjust the screen. All right, so case statements, they work a lot like an if-then statement in Java or Python, or a switch statement, if you know how those work. We use case statements to ask a question of the data and provide us with a response. So imagine a table with, you have heights of students in there. This is just going to be, we've got a table and we have a column called height, and that has the student's height in inches. So we could create a case statement that comes through here and says, when height is less than 60, then very short. When height is less than 66, then short. When height is less than 72, then average, else tall. Okay, first of all, we say I'm down here in short, so I'm not making fun of anybody, trust me. So, but the whole idea here is instead of just having a group of numbers, we can now bucketize these into 4 categories. So creates a categorical variable for us, which in a lot of times it's easier to work with that than it is to try to work with just raw numbers and when you're doing some analysis. So the syntax is really simple. You just start the phrase case, and then you have these with statements, these if statements, when, except they're called when. So we say when, then here's our Boolean question, then this is the response, short. And get to the end, notice there's no commas or anything. You have as many whens as you need. And the way this works is once it hits the first one, if it's let's say it's 64, it's going to say, nah, not that one. Bam, once it hits this one, it's done. It just leaves the case statement. It doesn't read the rest of the case statement for efficiency. So, but you have to figure in that way that you want to make sure you don't do it the other way around, because you'll never get to the other. Because if I put the 72 up top, we'd never get the very short or very short, because it would all go straight to average. So, plan it out correctly that way. But then, so go your whens, and then if you want, and this is not required, you can have an else statement. So this is like a default else. So if nothing else, call. Sometimes you might say if nothing else, no valid data, whatever it is, that's what your else could be. And then you have to end. You have to say end, and then this gives it a column name. So we're naming it. So this sits right in my select statement here. I'm going to bring up one so you can see it here. So it goes right in your select. So I select all from the table, comma, then I have a case statement. And here I did with price, and I created 4 categories, okay? Low cost, mid cost, high cost, and expensive. So if it's under $100, it's low. Under 500, it's mid. Under 1,000, it's high cost, but expensive else, so it's over that. And I just called these cost buckets. So I ended it as cost bucket. And you can see down here now I have a new column called cost bucket, which has my rates in there. So it just sits inside a select statement. So, and you can have as many case statements. You can have multiple case statements in a select statement. And you can have multiple Boolean. Like you could have where price is less than 100 and departments tools. You could add that in there to your case statement there. The only thing is you can't filter the results. So if I put this together, then I try to put a where cost bucket is high cost, it's going to say there's no such thing as a column named cost bucket, because the way, you got to understand, SQL looks at things in certain orders. And I think one of the first things it tries to go to is the where clause to filter out the amount of records right to begin with. So it looks at where before it even executes this case statement. Okay, because that way it does the where first, because it's like, hey, that if I can get rid of half the rows in the table, why would I have that? I don't have to pass it all through this case statement. So where is done ahead of time. So a solution could be we can pass it to a temp table. Now a temp table, and again, sorry, my screen is off balance here. Let me see if I can adjust it for you guys again. Okay. So one way you can filter based on the case statement is use a temp table. So a temp table is a table that you build, and it's only good for the instance you're in, meaning I'm logged into SQL Server. I build this temp table. It's worked the entire second I log out of SQL Server, that table is gone. It's been erratic. It's been erased from memory. These are really good to use because, you don't end up making a bunch of tables you don't need that's end up storing a bunch of data and eating up, your disk space because you only need to use them for as long as you need them for. So to create a temp table, it's pretty simple. The main thing about a temp table is there is a pound sign in front of it. This is a SQL server. I'm being very clear. This is a Microsoft SQL server. Well, it doesn't apply to other ones. Other database systems have different things like Teradata has volatile tables, that kind of stuff. So anyway, so so to create a temp table, really simple. I create this select statement from customer orders where department equals toys. And then right here between the columns in the from statement, I put into and then pound sign temp one. This is going to pass this will store the results of this query into this table. So this is not a view. So a view stores the query. So every time you run the view, the query has to run again. This query doesn't have to run again. All the results are now been dropped in a table. And you can just go ahead and check the table out just like you would any other table. You just select star from temp one, and there's your answers. But again, the second you log out, it's gone. I'll show you that in a second. So let's go ahead and I'm just going to jump into SQL Server now. See if I can find a better view for you. No, that's not the one. Let's try this one. All right, a little bit better. I'm going to adjust this one too, for us. So, all right, cool. All right, so I'm going to use that cust orders again. So I'm just going to just select, just so you can see the table, select star from cust orders. And let me see if I can make this. There we go, a little bigger for you. Okay, so I'm just going to run this. And there's gives my cust orders right there. So I'll do the same thing I just did there. We're going to do so to create a case statement, all we do is right into here, just bring this down and treat your case statements like a column. So it's like a column, even though it has all those lines, it's still just a column. So I say case first, then I start my order. Now you don't have to do it on separate lines. It just makes it so much easier to read. So I say when price is less than 100, then low cost. When price is less than 500, then mid cost. When price is less than 1,000, then high cost. And finally, we do the else expensive. Here, maybe I went a little too, there we go, back a couple. All right, there you go. And then you have to close out with an end. Now you don't have to name it. If you don't name it and I run this, you'll get the column, just the column won't have a name. So execute. There you go. So there's no name on the column. So, and that'll be a problem if you try to create a view or a temp table, you got to name it. So we'll just name it as, we'll call it cost bucket. Okay. So there it is. There we got my answers. But again, you can't query on this. Like if I tried to where, it's not going to find it. So the one thing I can do is I can add it to a temp table. So here we go. The temp table, you should always after your columns, and remember your case statement is a column. That's what you're creating as a column. And then you go from here, and we'll just say into, and I'll just call this cost buck, just because you can. And we'll bring this down a little bit so this looks better. And oh, so sorry, typo there. You don't need that in front of the into. Just into cost buck. Run this. There you go. 100. Now I can go down here and I can select star from cost buck. Okay. Execute this. I can add a where statement, so I can say where cost bucket equals expensive. And remember, we don't care about case in SQL. We're not case sensitive, so everything came back expensive. But now let's show you. I'm going to go ahead and disconnect. Let me move my screen a little bit for you guys here. So I'm going to go ahead and disconnect from the server. Then I'm going to connect again. Okay, now when I try to run this, because I am in the right database still, but now when I try to run this, it's not going to work. It's going to say, they're gone. Oh, wait, it ran. Son of a... All right, so apparently just logging out is not enough anymore. Once I actually closed out SQL Server, restarted the SQL Server Management Studio and got back in. Now, if I try running this, yes, it is gone. It's your temp table. It's no longer there. So just as a rule, you're going to have to keep creating the temp table every time you log back into SQL Server. I guess just a quick disconnect and reconnect wasn't enough to trip it. But anyway, so that is temp tables and case statements. They're useful. I use them a lot in the real world. Like I said, you're not going to be tested on this, but I just wanted to show it to you. You guys got a taste for it. And so again, so now the slide, if you go down here into this deck, if I put my case statement into the temp tables like I showed, call it different, then now you can query from the actual temp table. All right, so that's temp table and case statements. Now let's go ahead, let's just do some review. All right, so the select statement, let's start at the beginning. What do we need from the select statement? Okay, so first off, you have to have select and you have to have a from. So you have to have from, and that's your table. This is the most important. You got to tell what table am I trying to get my data from. Then from the table, we get to pick which columns we want. The select allows us to pick which columns. We have two choices. We can use a wildcard, the asterisk, which will return all the columns, or we can select our columns by just listing them, and you separate them by a comma. Okay? You can also change the order, because if I change this, so let's go ahead, I'll pop in real quick. Just, go by example. Take a quick look here. So if I was there, I've got that select star from, I think we were looking at cust orders. We'll just do it. I run this, what columns do we have? So let's just say I just want price and payment type. That's all I'm asking for. I print this out. You'll notice here it says price and payment. It's kind of small. So that's the order in the table. I can execute this. Now, if I want payment to be first, I can just put it here. I'm even going to leave it here to show you. You can actually you can run a column twice even if you want to, if you have a reason for it. So that it shows up twice, payment. So that's, you can move. So keep this in mind. So it's select tells which fields you want or columns from. This is the table you're coming from. Okay. So this is the most fundamental thing to know about SQL. Okay. Where allows us to filter by column values. So where select allowed us to filter the columns, which columns we want, this will allow us to filter records out by a column value, meaning in the column department, I only want the records that are equal to tools. And that equals, we use the equal sign. If we do want and do does not equal, we use either the bang equal or the two greater than less than facing each other. All right, now we want to look at some wildcards. We can use something like, can't use equals anymore. Now we have to use like. So we can sit here and say we're a department like T wildcard, this percentage. This means I want every department that starts with the letter T. So this is multi-character. You can use the wildcard of a question mark for single character. So if you had the question mark, it would just be, and it wouldn't bring back tools. This would bring back tools, but if you had one called toe, two, it would bring that back. So multi-characters will bring back as much as you want, and you can put it in the front or the back or even in the middle. You could have I could put an S at the end of this, and it would be, everything with the S too. So it would just get the middle points. And again, you have like or you have not like. These are your two operands to put in there. Okay, nulls are a little different. Nulls have an is statement where it's is or is not null. And this returns whether a column, whether a record in that column is null. Okay. Order by. Order by we use to sort columns. It's ascending by default, and ascending means going up. So it's A, B, C, D, E, F, G, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Descending you can get by putting DESC after the table. So descend if you want to go 10 down to 1, or if you want to go backwards Z up through A, that's what you'll get on that. So order by department description, order by department description, price. Now, I'm sorry, order by department descending I meant put here. So that's going to order by the department in reverse alphabetical order. You can also use 2 or more columns in your order by, and you can even have different ways. I have department descending, price ascending. So it's going to sort by department first, and then within that department, it's going to sort the prices. Okay, and it's going to sort them going up with that one's going down. Joins. Okay, there are 4 joins. Default is enter, I'm sorry. Then we have left outer, right outer, full outer. So to get that, we select star from students as S, T. That's our first table. This aliasing is not required. It makes it less typing you have to do. Because otherwise I'd have to write students here and tutoring here. So then we just go from statement, join to the table we want to join against. And because I've put nothing on there, this is an inner join. And then we say on. This is the primary and foreign key relationship. Okay. Student ID is the primary key in the students table. It is a foreign key in the tutoring table. So this is how the relationship goes. Okay. So inner join is, like I say, default. In most SQL RDBMSs, I don't know of one where it's not default. So I'm sure there could be one out there, but I don't know about it. So just typing the word join by itself means you want an inner join. You don't have to actually type the word inner join. You can, but you don't have to. And let me adjust the screen again. I realize we're a little off. Okay, sorry about this. Sometimes the slides all come out a little different shape here. All right. I got to adjust the size. 1 second. Sorry. Get a little smaller. All right. So again, the syntax for this is simple. Select from table A as A to table B as B on matching the IDs. That's what we're going to match on. Now note, when you do an inner join, look what happens. It only brings over matching things. So in this column, I have an ID of A, B, C, D. And in this column, this table, I have an A, C, E, F. The only matching ones are A and C. So they are the only ones that go over. There's no E and F, there's no B and D because they do not exist in both tables. So that's how an inner join works. It removes everything that does not, that there's no orphaned records, everything that has to match something. Okay. Great. If we want to get results, then we can craft a query like this. So we've got 2 tables here, billing and students. And notice I'm up here. Look what I'm doing. I've indicated which table these columns are from. Now, if you do not have a conflicting table name, you don't actually have to do this. But if you have the same table name, like, if you had a student ID in both tables, which you've got here, student ID, it has to know which one you're talking about if you want to put it up into the select statement. Otherwise, you don't have to. I just say this is very, very good practice. Just get used to it because it's not going to hurt. It doesn't hurt. It probably makes it better for you. I give the alias, we're using the alias, and also I'm choosing specific fields here, which, so again, we're doing the select statement with specific field. Full outer join. That's the next one. A full outer join brings in everything. So you see here, all these nulls. That's because it brings in everybody. It says, all right, we're going to take all 1, 2, 3, 4, A, B, C, D. Here they are. Notice you don't have a B or a D here, so table B, so you get null. That's number 2. E and F we brought over. There's no E and F here in table A, so this space is null and this space is filled in. If I did the same thing with the billing, you would see here's a case of somebody, this Gary, who doesn't have a bill. No invoice, no date, nothing. If I didn't do a full outer, Gary would not appear. If I did an inner join, Gary wouldn't, because Gary doesn't have a bill, so his name would not even appear in the query. Left outer and right outer are basically written by this whatever table's up first. So for a left join, the table you put in the front, the first table you list, will be the main table we go for. So table A, we will take everything from table A. Table B, we will only bring over things that match table A. So notice that we got values over for A and C. We have nulls for B and D because there's no value for B and D, but E and F are not brought over because we have designated this, the first table, the top one, as our join. Why we call it left and right versus top and bottom, top, because this is that you don't set it up by which order you write it in. It's because you're ordering on top. Then we have right outer join, where you can exact opposite happens. So E and F, now B becomes the first table because it's the right. Now you can make your life a lot easier. Number one, you don't actually have to write the word outer here. It's just left join or right join. And if you want to save yourself confusion, you do like most of us do. I just stick to left joins, and if I need to flip it, I'll just flip the table order, and that does the exact same thing. Okay. We're going quick because this is real. Group by, when using aggregates, remember aggregates have the parentheses in there. So max price here, this is our aggregate. Example sum average. If you have a non-aggregate in your select statement, department and payment are not aggregates. They're just regular labels. Then we have to put the group by, and you group by the non-aggregate values. The aggregate gets left out. So everything is not an aggregate. So if I had this and I had 30 aggregates and nothing else but aggregates, I wouldn't have to use a group by. But if I have one value that's not an aggregate, I have to group by. And what it does is it gives you a pivot table type solution. So you'll see it starts with clothing, cash, electronics, cash. Then it goes now, starts getting clothing, check, electronics, checkbook, and then you add. Okay. Finally, we'll get into having. Having's a special where clause designed to work with an aggregate. If I want to know which departments have more than 20 orders, I can very simply create an aggregate. I select department, I do a count. So this will give me a count of their orders, group by department. And then I can add this having count greater than 10. It'll only return the ones who have more than 10 orders. Okay. Notice I can put a where statement in here too, and denote the order. So it's from where group having. The where statement will filter first before you get into the having. So all the furnished ones will get filtered out before we even get into the having. So there you go. That's the quick review. Hope it was helpful. And we went quick on the backside, but it was all review. So good to see you. Good to see you in class again.